So are there El Niños in the other oceans? We will see that in a minute. But let's first look at a few of the big El Niños that have happened. This book is already old because we had another monster El Niño in 2015. 2014 looked like it was an El Nino, but it just continued into 2015, and then 2015 became a monster El Nino, which means very strong warming going all the way up the coast into Alaska and tip of South America and so on. So 1982-83 was one of the first one that was observed, and then we started going back to ocean sediments and corals and so on, which can give us hints about past big El Ninos and so on. So there is some reconstruction of past big El Ninos, but in the instrumental record, we very well captured the 1982-83 El Nino because some satellite data was already being collected. In fact, many of the people at NOAA who collect this satellite data thought that this is so warm that it must be wrong, so they threw out the data. They didn't know that an El Nino was going on and that was giving real warm temperatures, so they didn't know, right? The other one that then got observed much more with many satellites that measured winds, chlorophyll, forests, rain, etc., happened in 1997-98. Why do we say 82, 83, and 97, 98? As we said, El Nino peaks in December, January, February. So December of one year going into January, February of the next year. So 1982 would already be having El Nino becoming obvious coming into December, and it will peak in January, February, and then decay away. So it has a life cycle where its onset happens, its growth happens, its maturity happens, and then decays and goes away, right? So 97, 98 again grew in 97, extended into 98, January, February, and then decayed away during 98. So created, these figures here shown are the west coast of the US and sea surface temperature anomalies for a El Nino year and a La Nina year. Flooding, drought, erosion, fires, tropical storms, harmful effects on marine life that we talked about. How is coral affected? Basically, corals like to live in a certain range of temperature and salinity and close to the surface, right? So you can change sea level and drown them, or you can warm the sea surface temperatures and bleach them, where the symbiont algae that live on them die away. The colorful coral structure becomes blanched, looks bleached. That's how corals can get affected. Or you can dump a lot of rain and change salinity and also affect the corals, right? So El Nino and La Nina are both able to change temperature, sea level locally, and precipitation and salinity, right? So they can be unpredictable, but there are constant efforts to predict them using weather and climate models. Let me touch on the El Nino-like behavior in the other oceans. This is the Indian Ocean, which is supposed to be an animation, but unfortunately it doesn't seem to be working. But essentially, you get some years where the normal temperatures are warm everywhere. Remember, we said there is no strong upwelling in the east in the Indian Ocean because of the monsoonal circulation that changes with the season. Once in a while, you get very strong upwelling in the east. This is not the best figure, unfortunately, but you can go and look for the Indian Ocean dipole, it is called. Not everybody agrees with this terminology, but nonetheless, it's called a dipole because it's cooler here and warmer there, but not always. But nonetheless, the terminology exists. So you can find these figures online. So that happens during September, October, November, as opposed to December, January, February, when El Nino happens. And because this ocean is smaller, it happens only for 3 months, as opposed to 12 to 18 months that the El Nino happens. A similar thing called Atlantic Niño happens in the Atlantic Atlantic Ocean, you can see there is warmer temperatures in the east, cooler than normal temperatures in the west, has impacts on the ITCZ and the rainfall over Brazil and West Africa, and also over the Indian monsoon. So that's called Atlantic Niño. Again, Atlantic is very small compared to the Pacific. So this El Nino in the Atlantic, like the Indian Ocean, also lasts for only one season, and it tends to peak in June, July, August. Okay, so El Ninos happen, the east-west sloshing happens in the Indian and Atlantic Oceans as well, but they are much smaller. So the life cycle is shorter, and because the heat sources are also smaller, their impacts are also not as global as El Nino. El Nino is a monster because the Pacific is big and it goes on for a long time. How are things predicted? Basically, we are constantly monitoring temperature, thermocline, winds, rain, salinity, and so on, currents in the ocean by using various platforms. I mentioned Argo, Deep Argo, which is measuring currents deep in the ocean temperatures. There are BGC Argo, which means biogeochemical Argo. There are surface drifters. There are volunteer observing ships, which means ships that are carrying cargo can be instrumented to measure temperature and salinity along the way. We do this also with airplanes. Airplanes, as they're flying around, they can measure atmospheric properties and so on. So this looks like a lot of data, but actually it's not ever enough to properly monitor the ocean, the changes, the global warming, the sea level rise, and so on and so forth. Nonetheless, international bodies exist which organize this, coordinate this. International partners make this happen. India is a big partner in many of these activities, like the red moored arrays, they are called. So these red lines here in the Pacific are called tropical atmosphere, global ocean kind of terminology that is going to be replaced with something else soon. This is called a Rama here in the Indian Ocean. It's called Pirata here in the Atlantic Ocean, and so on. So data is constantly beamed to the satellites. Satellites are sending that information to climate centers, weather centers, and you can go online and find El Nino predictions constantly being put online, and the predictions look like this. So this is made in let's say early August of 2020, and it's predicting conditions, probabilities of La Nina, neutral or normal conditions, and El Ninos going into 2021 March, April, May. So it started in August. So this is for July, August, September of 2020, August, September, October of 2020, and so on into November, December, January, February, and so on into 2021. What is it saying? Basically, it's saying that as we go along in September, October, November, and October, November, December into early 2021, the probability that there will be a La Nina in the tropical Pacific is greater than the probability that it will be normal, and the El Nino probability is basically very small. So there is a high probability of almost 60% or greater that this year will be a La Nina, which is why I said earlier that it should be a strong monsoon in September. Monsoon has not completed yet, so maybe we'll get some heavy rain in September because of La Nina. It's not always clear whether El Nino is affecting monsoon, or La Nina is affecting the monsoon, or monsoon can also affect El Nino and La Nina. These are complicated, dynamic questions that we won't address, but such forecasts are being made. Their skill is good. The predictions are reliable, but they're given as probabilities because if it's a 60% probability of a La Nina, based on whether you are a financial company, insurance company, reinsurance company, a farmer, a fisherman, a health worker, you can use this information to make proper decisions. That's the goal. So predictions are made, they are skillful, and they are used by various sectors for various decisions. Okay? So you can go online, find the data in the ocean being beamed and places like the Pacific Marine Environmental Laboratory of NOAA in Seattle, Bureau of Meteorology in Australia, and the forecasts are being put up by various labs like the International Research Institute in Columbia University and so on. Okay? Again, very good field to get into because it affects real life decisions, affects life and property, and you can save life and property by improving forecasts.